Welcome back to Engineering Acoustics. Hi, this is Professor Ryan Harn. We know about sound transmission class, which characterizes sound transfer between rooms. In this video, we'll learn about a sound level metric that quantifies how sounds transfer from one floor above to the floor below.
So let's get started. Footsteps, the drops of fitness equipment and other household objects, and a wide variety of other impact noises are the common nuisances of sound transferring from one floor to the next. So the impact creates vibration in the floor and joists, and then that re-radiates a sound via the drywall ceiling or in the walls. It's a common need to quantify noise insulation capability of the floor treatment from one floor to the next for the same reasons that we would want to quantify sound transfer from one room to the next to the walls. An impact insulation class is the metric that was created to help us quantify how well a floor treatment insulates one floor to the next. Now, unlike STC, IIC must necessarily induce vibration, since vibration is the primary mode by which noise transmits between floors. So the measured transmitted signal is actually sound that's recorded in a room below the floor that's being excited. So in other words, while STC is relatively easy to measure, IIC requires an extensive test facility for this metric to be evaluated. So how is it evaluated? We take our floor treatment and we prepare it according to the ASTM E492 standard. Now, below the floor is a room. This is a reverberant room. In this case, it's a wood frame with nothing particularly on the walls or floor except drywall and then a concrete floor. Impacts are then applied to the floor over the room with a machine that's placed at several strategic locations. And we measure the SPL at locations in the room below and then spatially average their overall 1/3 octave band recordings. Sound into the room must only occur through the floor, not through any other means. So the isolation of the path must be very strictly related to the floor over top of this room. A tapping machine is used to produce the impact that creates vibration and thus noise through the floor. The tapping machine contains a central crankshaft and mallets that move linearly up and down that hit the floor with a moderate impact. Then sound builds up in the room below to a steady state level, at which point we acquire the SPL in that room. Here's the tapping machine in action. For such a simple behavior, these machines are quite expensive. The IIC is then determined from our SPL readings in a way that's similar to STC. So we compare the SPL readings in the 1/3 octave bands to a tabulated list of IIC readings. We won't go into any further detail of the method since IIC is much more involved to compute. Let's put this into perspective though, because impulsive noise is something that people are very sensitive to. So walking, thuds, drops, and so on are much more common from floor to floor than between neighboring walls of adjacent rooms. So floor installations themselves might include variables that could cause issues with us interpreting IIC in practice. In other words, there are many ways sound could flank our floor treatment. Flanking is when sound travels through a path of least resistance that is overlooked in the design process. So sound that is coming from the floor above may actually be radiated by the walls and not by the ceiling, due to the fact that the floor and joists also connect to the wall framing. So it may actually be difficult to replicate IIC in practice, since the whole installation is involved in the transfer of sound from floor to floor. But there are ways of enhancing IIC and ensuring that there is great noise insulation between floors. The first and foremost way of enhancing IIC is to program the space. Never put a foot traffic area above a bedroom. Instead, place rooms of similar functions over each other, whether this is in a residential space or a commercial or industrial space. Place damping at the points of impact. So underlayment, whether that's a carpet underlayment or a rubber underlayment, this will help suppress shock transfer, like the carpet underlayment that's shown at the top right. Insulation in the cavities is important to reduce the mid to high frequency noise, especially when the floor above is a hardwood surface. Finally, mass. Concrete floors are much better at enhancing IIC than stud or wood joist construction, although this comes at much greater cost. To understand what we should expect regarding IIC values, we need to recognize that any floor that's constructed and is actually able to support the static weight of a building will result in a fairly high IIC of at least IIC 30. An IIC of 50 is marginal in terms of how people would feel insulated between sounds coming from rooms above them. IIC of 70 would result in almost no complaints ever, since the people would be almost perfectly insulated floor to floor. Let's look back at our floor joist construction. In this case, there's a hardwood floor, a joist construction that directly supports the drywall ceiling to the floor below. This structure will result in an IIC of 33 without any particular attention to mitigating shock transfer. Now, if we fill the cavity with insulation, the IIC increases to 42. And if we resiliently hang the drywall, the IIC increases to 52. Now, the cost of this installation is starting to rise, as we've not only added insulation, but we had clips all along the joists that help support the drywall ceiling. Considering the fact that if we simply had installed carpet instead of a hardwood floor, we would have resulted in an IIC of 65 without even needing insulation and without even needing the resilient springs that support the drywall ceiling. This needs to be taken into consideration, since oftentimes aesthetics might come in the way of good acoustic design. So let's summarize what we've learned. Impact noise insulation is a major consideration in the design of floor treatments, since people are very sensitive to impulsive sounds. IIC is the standard to quantify the effectiveness of floor treatments to mitigate sound transfer. Measuring IIC, though, is much more difficult than measuring STC. IIC requires dedicated facilities and equipment for its measurement. Now, to enhance IIC, simple guidelines can be considered, but sometimes the aesthetics for a consumer or client are of preference that may lead to inherent challenges for us as designers and acousticians to stop shock noise.
That's it for this video. In the next video, we'll learn how all of the sound incoming into a room affects speech intelligibility.